This is our sun. We might as well put Earth here for comparison. And I'm gonna put Earth right here at 1 astronomical unit away from the sun, right around here. Perfect. And this is Earth in comparison to the closest stars to our solar system. I don't know what's going on here with Earth. It looks a little bit funky. A little bit too funky, actually. But if you look into the skies, you'll see the nearest stars that you can actually see in real life as well. And so what we're going to do is we're going to go and find Rigel and then make it go supernova and then see what that looks like. So imagine if Rigel one day decided to go supernova on us. I should probably enable the grid so you can see the distances involved here. So this is Sun. And Alpha Centauri, which is one of the previous YouTube videos I made, was kind of talking about how what it is and how distant it is from us. So this is it's a dual 2.5 binary star, meaning that it's a binary star, but it has a tiny third star that's actually a brown dwarf flying around it. Wolf 359, that's another brown dwarf. It's right here. We have Sirius, that's a very bright star that's right there, and that distance is about like 8 light years, maybe 7 something light years away from us. So basically light will travel for 7-8 years before it gets to Sirius. And where is Rigel? I thought it was somewhere here. Maybe I'm totally wrong about it, but I swear I remember seeing Rigel. Maybe not. All right, so we do have some other massive stars next to us here. We have Altair. So we can actually switch to Altair. Actually, it's not as massive. It's only 1.77 mass of Sun. But Sirius is 2 masses of Sun. Procyon is 1.5. And is there anything else that's more massive? Something really, really cool. Because I want to see some really cool supernovas here. No, nothing. Alright, so the easiest way to get a supernova going in this simulation is to basically just wait, because none of these stars are orbiting around a central black hole. So if you were to accelerate time, at some point, 2 of them will come close together, and because their masses will combine, they will initiate a supernova. And that's what we're going to do right now. We're going to wait a little bit for one of them to go into supernova, or 2 of them, that is. I think it's probably these 2 guys that will be first, because they're really, really close already, and they're not really orbiting around each other. And supernova number 1 is going to occur any second now. 15 years. Oh, there we go. Okay, Alpha Centauri was the first. Increase this to hours. And let's go back to the Sun, specifically Earth. So we're gonna go back to Earth and jump on its surface and look into the sky. So we're gonna see what this looks like from the surface of Earth if we were to experience a supernova. Oh, this is beautiful. Supernova from Alpha Centauri. Okay, so it shouldn't be blinking that much. I think that's also a bug. But essentially, this is what would happen. So this is only hours, not hours, sorry, maybe days away, days after it occurred. Okay, this is not looking too good because we're spinning so much. Let's look at it from this angle. Where is it? Here it is. All right, so this is what it would look like in the night sky. And let's accelerate time. So this is maybe about a year after, I guess. And let's go into minutes, months per second. So it's gonna come closer to us. So this is obviously if the Alpha and Beta Centauri decided to collide into each other. And after a few years, because this material is moving at like 30 kilometers per second, after a few years, not a few years, but many, many years, it would actually make it to our solar system and come for a long visit. A very long visit that would most likely destroy everything on our planet. The thing is, we don't really have to worry about this because astrophysicists have determined that there's not a single star in the vicinity of 200 light years that is actually, I think usually that's enough for us to be worried about things. But in the vicinity of 200 light years, there's not a single star that would actually go supernova anytime soon. So we don't really have much to worry about. This is just a simulation of what would happen if there was a star that could go supernova. But there's nothing nearby. So we don't have to worry. But let's just watch and see what happens. I can't even tell if it's here yet. Okay, yeah, I think that's it. Oh, what's happening? So this is 50 years later. I think we're inside of it now. I can't really tell, but I think we're actually inside of it. So the temperature hasn't actually increased, but this would obviously increase the temperature, blow away the atmosphere that we currently have, and would cause some serious problems. Oh, look at that. There's another supernova happening right there. Awesome. So now we have 2 supernovas. And both of them will make their way here. There's going to be a lot more, I think. There's going to be way more. So this is essentially because there's nothing to hold these stars orbiting around a central location such as the black hole that we have. And that black hole is known as Sagittarius A. It's about I think it's like 4.3 million masses of sun. And that black hole is right in the middle of our galaxy. But these guys don't have that black hole. They just have nothing. They're basically they were stuck in place, but now they're attracting each other and smacking into each other and bringing their solar winds to our solar system. Alright, let's accelerate this more. And the second solar flare thingamajig, not solar flare, this is solar wind to the extreme, solar dust I guess, is going to make it to our solar system any second now. But essentially, yeah, this is where the life would actually end. The life would be no more. So many bugs here with the visual effects though, but that's okay. I'm going to forgive the game developers because they're absolutely awesome. The guys who made this game are actually very personable. They love to chat with their fans. They respond to their emails really fast. So this game is developed by some really cool people. And I don't know what's happening here anymore. I think there's more than 2 actually. But I want to wait for all of the stars to collapse into each other. And let's actually we can't really see anything from the inside. Let's look at the outside. Let's see what happens after. This is after 430 years. Let's keep going. Let's keep going until nothing is left. But you can kind of see the stars coming closer together. So all of these guys are slowly flying toward each other. And if you actually go through this simulation and you look at each individual star, you'll notice that none of them are really that massive. That's why supernova would be impossible in the vicinity of our star, because none of these guys are massive enough to cause a supernova. They'll just kind of, what will happen to them is they'll expand to a dramatic size, swallow everything in the vicinity, and then basically shrink into a white dwarf and disappear with time. They'll just kind of burn away into infinity. But they're not going to cause any serious damage to us. That includes all of these other stars like GJ693. Didn't know that existed. WD1142645. I guess they kind of didn't really know what to name these guys. But they should definitely name these stars because these are our closest neighbors. Neighbors need names. This has a name. It's called Delta something. I can't see it. Delta Pavonis? Is that it? I think it's called Delta Pavonis. And there's another named star called cannot pronounce that. Afiuchi. Sounds like some kind of a pasta. They're still kind of far away. So I think the stars that have exploded that went supernova were the binary stars. So this is how many binary stars we have around our solar system, in the vicinity of our solar system. But the other ones, like for example this tiny one, Barnard star, which is actually only about 14% of mass of our sun, and these other guys, they're still kind of slowly flying toward each other. It's going to take them really a long time to get to one another because they were like light years away from each other. So even if they were traveling at the speed of light, it would take them years. So even after like 5,000-6,000 years, they're still far away. And that kind of gives you an idea of how far things are in the solar system. Not in the solar system, in the galaxy, in the universe. Okay, yeah, that's not gonna... it's not gonna take... I mean, that's gonna take forever for them to get to each other. They're not even moving at meter per second yet. That's ridiculously slow. So that's basically... That kind of shows you how little gravitational attraction there is between different stars in our galaxy. However, Sirius is moving really fast. 1,186 kilometers per second. I don't know where it's flying, but it's flying somewhere. These guys are moving pretty fast as well, 172 kilometers per second. But I think I'm not sure if there's really any need for us to wait for them to collide. You kind of get the idea. This is essentially what happens if you run this simulation.